Now, let's talk about rational functions. The general form of any rational function is, I have f of x to be equal to ax plus b over cx plus d. I call it a rational function because it comes as a fraction. And I consider the fraction to be a ratio, so I consider it as a rational function. Let's say we want to draw the function f of x equals 1 over x, and I have, in this case, to exclude the 0. The shape of my function would be this is the shape of my function. You can realize that now we have two asymptotes. We have a vertical asymptote. This is a vertical asymptote, and we have a horizontal asymptote. Before sketching any curve, we have to know our vertical asymptote and to know our horizontal asymptote. So, now, 1 for our vertical asymptote simply is equal to, I add the denominator of the fraction I and make it to 0, so cx plus d is equal to 0. So the equation of the vertical asymptote x is equal to minus d over c. Now, for the horizontal asymptote, simply the equation of the horizontal asymptote equals the coefficient of x in the numerator divided by the coefficient of x in the denominator. So the equation of the horizontal asymptote is simply y is equal to a over c. If there is no x in the numerator, then I substitute instead of the a 0. And then I can say that 0 over anything will give me a 0. Let's have a question now from the IB question bank. Consider the curve y equals 1 plus 1 over 2x, for which x can't be 0. For this curve, we need to write the value of the x-intercept. Okay, for part AI, the x-intercept is when y is equal to 0. So I substitute 0 is equal to 1 plus 1 over 2x, and I can use the solver to solve my equation. I go to the solver, we exit, let's delete all. I have 0, which is equal to 1 plus 1 over 2x, and this will be equal, I execute again. So the value of x equal to negative half. So I have x to be equal to negative half. This is the x-intercept. Part A double I, we need to find the equation of the vertical asymptote. The first thing we have to do, we need to write it as a single fraction. Write as single fraction. So I need to make the same denominators. In order to make the same denominators, I multiply this one. I will be considering having y to be equal. This is 1 over 1 plus 1 over 2x. So I have to multiply the numerator and denominator by 2x. and then add them up. So I will have the y to be equal to 2x plus 1 over 2x. Now, for the vertical asymptote, I simply need to make the denominator equal to 0. So now, for the vertical asymptote, I take the denominator and make it equal to 0. 2x is equal to 0, having the vertical asymptote to be x equal to 0. So, I can understand now on my function, I can add the vertical asymptote to be x equal to 0. This is the equation of this vertical asymptote is x equal to 0. And I know that the function will cross the x-axis at the negative half. So it crosses the x-axis at the negative half. This is the negative half. In order to view its shape, I need to use my graphical display calculator to sketch it. So I go to menu, I go to graph, and I clear. So I have 1 plus 1 over 2x. And then I fix the V window. Let's get it standard. The x is from -2 to 4. And let's keep the y. Exit and I draw. So I have this function this way. But first, let's do some extra work and find the horizontal asymptote before drawing. Now, the horizontal asymptote, the equation of the horizontal asymptote is y equal to the coefficient of x in the numerator over the coefficient of x in the denominator, which is 2 divided by 2, having the horizontal asymptote to be 1. So my horizontal asymptote is y is equal to 1. Let's add the horizontal asymptote on our curve. This is y equal to 1. And after that, I can sketch the curve that I have on my graphical display calculator, given that it must cross the x-axis at the negative half. This is the shape of my curve, so let's sketch it together. It will be having this shape. It will never touch the asymptotes. So by this, I could sketch the rational functions by first indicating clearly the equations of the horizontal and the vertical asymptotes.